Good morning. Today we continue with our analysis of agile software. So yesterday I was reporting on one software disaster, the virtual case, software for FBA and FBI, sorry. And so we described the fact that this was actually a failure and was cancelled after 5 years. But actually that was not the only one. And there is a long history of software failures in the history of software development. And in fact, if you go on Google and you look for project failure case studies, you have a lot of search results. And in fact, for example, there is a Computer World, which every year publishes this article, The Scariest Software Project Horror Stories, in 2012, 2013, and things like that. And it's actually very scary. I mean, you look at this and you mean you are not happy about the status of software development in the world. For example, this one, US Air Force pulls plug on ERP project after blowing through $1 billion. Okay. Or another one, California court throw huge software project on scrap heap. So basically they were, a project was intended to modernize case management for California's court system, was scrapped in March, despite the fact that officials deemed the software development so far was viable. The problem, not enough money to continue rolling out. And let's see another one. Manufacturer sues IBM over SAP project disaster. Okay, so it's not just small companies that make this kind of error, but also big companies, of course. And there are many stories like that. Also in Agile, I mean, Agile is not the solution. You can have problems with Agile. For example, this Slashdot webpage reports that Universal Credit, the plan to consolidate all Britain's welfare payments into one, is the world's biggest agile software development project. It is now close to collapse, the British government admitted yesterday. The failure, if and when it comes, could cost billions and have dire social consequences. So it's actually not very nice. So this webpage by Jeff Atwood, a very famous blogger in the field of software development, reports on the long, dismal history of software project failures. And this year, organization and government will spend an estimated of $1 trillion of IT hardware, software, and service worldwide. Of the IT projects that are initiated, from 5 to 15% will be abandoned before or shortly after delivery as hopelessly inadequate. So the percentage of failure is about between 5 and 50%. Big failure, okay? And are things improved? So is it going better? Yes, because in '94 a study was saying that the rate of failure was about 34%. Okay. Sorry, 34% is the project success rate. Okay. The 10th edition of the annual Chaos report on the Standish Group, which researches the reason for IT project failure in the United States, indicates that project success rate have increased to 34% of all projects. That's more than a 100% improvement from the success rate found in a first study in 1994. Okay, so there is actually an improvement. So failing is okay. Failing can even be desirable, but you must learn from your failures, and that requires concerted post-mortem introspection and analysis. So yes, failure is still okay as long as we are going to improve, and software has improved, thanks also to the fact that we are changing the way we develop software. Also, this article by IEEE Spectrum, Why Software Fails, is actually quite interesting, so I recommend it to you. And there is some nice stories. For example, here is saying that this is a story that nobody knows is true, but it's entirely, um, it looks like a true story. So have you heard the one about the disappearing warehouse? One day it vanished, not from physical view, but from the watchful eyes of a well-known retailer automated distribution systems. A software glitch had somehow erased the warehouse existence, so for the warehouse were rerouted elsewhere, while goods at the warehouse languished. Because the company was in financial trouble and had been shuttering other warehouses to save money, the employees at the missing warehouse kept quiet. For 3 years, nothing arrived or left from the warehouse. Employees were still getting their paychecks, however, because a different computer system handled the payroll. When the software glitch finally came to light, the merchandise in the warehouse was sold off, and upper management told employees to say nothing about the episode. This story has been floating around the information technology industry for 20-some years. It's probably apocryphal, but for those of us in the business, it's entirely plausible. Why? Because episodes like this happen all the time. Last October, for instance, the giant British food retailer J. Sainsbury plc had to write off its US $526 million investment in an automated supply chain management system. It seems the merchandise was stuck in the company depots and warehouse and was not getting through to many of its stores. Sainsbury was forced to hire about 3,000 additional clerks to stock its shelves manually. So, not bad. So software failure costed a lot, and they were forced to hire 3,000 employers. And here you have the software failure Hall of Fame, with year of happening, and the name of the company that was involved, and the amount of money lost in US dollars from 92 to 2005. So not bad. Okay, and also of course the article goes on describing the reason and other examples of loss and why projects fail so often and so on. Okay, so we already described some of these reasons why such big projects fail, and one of the reasons is the fact that there is not a clear match between requirements and what is being produced, and the match is not there because requirements are not easy to be made. And the percentage of projects that is now being successfully delivered has increased a lot. And this is due to the fact also that these projects tend to be much smaller now. So smaller projects are easy to correct. There is another case studies you can read if you want. And this is Denver Airport baggage system case study, which describes what happened and why it happened. So, underestimation of complexity, complex architectures, changes in requirements, underestimation of schedule and budget, dismissal of advice from experts, failure to build in backup or recovery process to handle situation which part of the system failed, the tendency of the system to enjoy eating people baggage. So yes, at the end it was a huge failure. So agile wants to go over this problem and improve a little bit. So agile methods is not just one single method, but there are many methods that have to do with agile. And in particular, over the years, many have proposed different methods for applying the Agile Manifesto. So the Agile Manifesto is just principle, and then of course there are many methods based on this Agile Manifesto. So we have seen a few of the principles of the Agile Manifesto, and the principles have to do a lot with the technical organization of the work, but most importantly, they have to do with managing human beings, because programmers, after all, are human beings. And the Agile Manifesto acknowledges this, and so it puts a lot of emphasis on creativity and the well-being of software developers. In fact, what happens is that software development, when it goes wrong, it puts a lot of pressures on people and burns out developers in some sense. So it's not uncommon, for example, in the States, to have companies where people work 12 hours a day for several weeks or months. And this is not okay, because programming is an intellectual challenge, and so you cannot have you cannot solve intellectual challenges when you are very tired. So the idea is that you should stop working off office hours and just keep a maximum of 40 hours per week, which, by the way, it's the European standard. So at least in the United States, they finally acknowledge that working too much is not productive at all. So if you look at the principles of the Agile Manifesto, you will see that a lot of these principles have to do with people. And so, for example, business people and developers must work together daily. So a lot of emphasis of interaction of people, of human beings. Build projects around motivated individuals. So it's very important to give them the environment, the support they need, and trust them to get the job done. So people are not considered like simple code machines, but individuals that they can think and take decisions individually. So as you will see later in the Scrum approach, programmers are given responsibilities, actually. So they decide what to do, they decide how to do. Most efficient and effective method of conveying information to and within a development team is face-to-face conversation. So drift away from the standardized memorandum and documentation that goes from desk to desk, and then move to face-to-face conversation. And then sustainable development, okay? So constant pace, not too fast, and not try to burn out people. So a lot of emphasis on people. And this is quite important. So you have to understand that programming is a human activity, and it's not just technical, it's not just computer science. It also has to do with sociology in some sense, because you have a team of people that together have to realize an intellectual challenge, have to try to solve an intellectual problem together. So it's not just mathematics, but also sociology, right? So you have to make sure the team works well together and people can talk each other and help each other to realize something. And in particular, if you have one piece of work that one guy will do in 1 year, but just hiring 12 people for doing that work, it doesn't mean that you are going to take 1 month, because it doesn't scale like that. Communication, it's very important. And so if communication is done very nicely in a very good way, then everything is going to work fine. Otherwise, you actually, by adding more programmers, you are going to make things much worse. Okay? We have many software development methodologies that are based on iterative development and the Agile Manifesto. And all of them basically are based to the fact that you have to do iterations. So iteration with frequent inspections means that you have to do small amount of work and every time check with the customer and have some feedback on how things are going. So it's a sort of feedback mechanism. So teamwork, self-organization and collaboration, this is also very important in agile methodologies. So a lot of emphasis on the human being. And finally, development aligned with customer needs. So continuous feedback from the customer. So what is Agile for? Agile is not for reducing time to market or reducing costs, and maybe not even for faster development. Agile is for adapting to change, and so improving the rate of success stories, basically. So it's very important to be sure that in any company, the management understands what does it mean agile. So if a manager expects to reduce costs, maybe it's not going to be happy when agile method is implemented. So be ready for changes. In traditional process development, there is assumption that the change is a problem because it increases cost. But since changes cannot be avoided, agile methods just address the need for change. So, as I said, one of the main pillars of agile methods is to divide the development process in small iterations, so small increments. And every small increment has minimal planning and does not directly involve a long-term planning. So you have to work on small things and build your software incrementally. An iteration is a short time frame from 1 to 4 weeks. The idea is that since after every iteration you get feedback, the benefit is that you can adjust to change. And so you minimize the overall risk, you adapt to changes very quickly, and you reduce the final time to market. So one of these agile methods is the extreme programming method that was proposed for the first time by Kent Beck in '96. And another agile method, it's the one that is explained in these slides, is Scrum. Okay, so extreme programming, I'm not going into the details of extreme programming, but some of the ideas are quite nice, and actually they can be used together with Scrum. So one thing is to sit together, so programmers should stay in open space and communication between programmers. Another one is pair programming. So the idea is that instead of everybody programming on his piece of code, people sit together in pairs. So one guy starts to program and the other one just watches what he's doing and interacts with him. And I have to say that this is a quite nice experience. I don't know if you ever try to program together with your colleagues, but it's a very nice experience. Because what happens is that while you are concentrating on writing code, the other guy can actually see what you are doing and maybe find immediately errors that you are introducing while programming. And also what can happen is that you can discuss a little bit various solutions, and since 4 eyes see better than 2, then you can discover problems quite earlier in the programming practice. Of course, managers don't like this kind of pair programming because they think it's a waste of money, because one simply sits inside the computer, in front of the computer is programming. The other one is just watching. So it looks like a waste of time, right? You are using two programmers when you can use one. But it's in fact, if the two guys go well together and are good friends and they don't fight over every line of code, then it could be a very nice experience. So sit together, pair programming, whole team. It means that one guy works on one project and is not allocated to several projects at the same time. Nice workspace with blackboards and things, and maybe places where people can meet and discuss on the project. And energized work, so work less but more intensively, so be more productive. When you are sick, rest and get well. And when coding, turn off phone and email notifications. So concentrate on the work. So work less but more concentrated. And finally, 10 minutes build. That means that build and test shouldn't take more than 10 minutes. Then continuous integration, we already discussed this. So this means that every time you commit, you have to compile and test as well. So you never commit something. Incremental design, so daily attention to design. It's not just design is one thing and coding is another one, but coding and design as one single activity that is done together. Team continuity, that means that the same people work on the same project all the time, so you don't change too much. And finally, single code base. That means not too many branches on a project, otherwise it's going to be difficult to manage the different branches. So Scrum doesn't provide really this practice, so it can be integrated very well with the extreme programming. And so usually it's associated with object-oriented programming because it gives, it seems to be very well adapted to object-oriented programming, but of course it's a generic method, so it can be applied to anything. So in Scrum, there are three things that have to be considered. The roles, so what people are, and how the entire team is organized. The artifacts, so the things that are going to be produced during the project, and meetings, so what kind of things we discuss when people meet together. So for roles, there are basically three roles. One is product owner, Scrum Master, and the team. The central thing is the team. So the emphasis, the real emphasis is on the team, which is the one that is going to develop the code. And then the other two, product owner and Scrum Master, are more or less things that help the team to achieve its goal. The artifacts are the things that are going to be produced. So as you will see later, sprint is basically the small iteration, and release is what is going to be produced at the end. And then the meetings, you have release planning, sprint planning, daily scrum, sprint refinement, so very different kind of meetings. So Scrum is based on the research by Takeuchi and Nonaka, so two Japanese researchers. And as I said, there is no waterfall, and everything is iterated. And there is not a traditional division of labor. So the team is self-organizing. One nice thing is that Scrum originally started in hardware, not in software. So it's not something that comes directly from software, but it's something that comes from hardware, actually. And has been introduced in software in '95 at the conference on object-oriented programming languages and applications. And it's now used by basically every single large company from Yahoo, Microsoft, Google, Nokia, Siemens, Motorola, and so on. Scrum has a very simple set of rules. So these simple rules have very deep implication in the organization. So it's basically impacts on the organization of a company because it changes the roles, It changes the mindset and changes the development process. Okay, so I will just go directly to the main thing. So the first thing to understand in Scrum is the iteration. So the iteration in a Scrum is called sprint. So the development is divided in fixed length iterations called sprint. And one iteration has a fixed amount of time, so the fixed length. And it must be decided at the beginning by the team. It can be 2, 3, or 4 weeks. So typically is a multiple of a week, and it can be 2, 3, or 4 weeks. So you start Monday, and you finish like Friday of the next week. So 10 working days, let's say, okay? Typically, in average, if you go into industry and you ask and you make a poll on how many weeks of iteration in a sprint, most of the companies, they choose 2 weeks. So 2 weeks seems to be the most appropriate length for a sprint. So at the end of each sprint, the team must have created a potentially shippable product increment. That means that it doesn't matter what you are going to produce, but what you produce should be shippable. So it should be something that actually runs. So it should be something of production quality, properly tested, and properly documented. Okay? The end of the sprint cannot be referred. So it must be 2 weeks. In 2 weeks, you have to close. That's it. You cannot say, oh, we are late, we are going to take 1 more week. No, that's forbidden. 2 weeks, and 2 weeks you have to complete everything. So it means, what is everything? So everything is, we will see in a little while, but this actually can be very little or can be very much. It depends very on what are the goals of the teams decides at the very beginning. So, as I said, the end cannot be deferred. So, if some functionality cannot be completed, then it's deferred to the next sprint. Okay? So, the important thing is that at the end of the couple of weeks, you actually have something that runs and of production quality. So, properly tested, properly documented. No one is allowed to add work to a sprint once it's underway. So once we start, at the very beginning, we are going to decide what we want to do. During the sprint, we work for building that features and that functionality. And once we have decided what we want to do, we can drop work if we feel we are not going to complete, but we cannot add new work. In exceptional cases, an entire sprint can be cancelled if it no longer makes sense given the circumstances. But that's very uncommon, okay? Because it can be traumatic to the team. The predictability of the project is controlled at least each sprint, so that the risk that the project may go out of control or become unpredictable is contained. So basically, the sprint is the minimal pieces, the minimal piece of work that must be done, after which we are going to have some feedback. Okay, so PSPI means potentially be shippable product increment. This is something very crucial, so please memorize this acronym PSPI, which is very important in Scrum. The length is fixed. As I said, 2 weeks is the industry average. It's the suggested length. And why this so? Because smaller goals in time create the urgency for cooperation. So shorter iteration force the team to cooperate, and it also forces people to not use a mini waterfall, because you have only 2 weeks, so there is no time for a full waterfall model from requirements, design, and implementation and testing in 2 weeks. So you have to do everything at once. Of course, okay, these are the technical benefits. We are going to skip because we already talked about that. So we said that we cannot extend the time box. We cannot reduce the quality of practice. So if we decided that there must be at least so much testing, we have to keep it. Okay, so we cannot reduce the quality. Quality is not a control variable and cannot be reduced. But we can add more resources, so we can take one more guy and add it to the team. Or we can change the scope of the item. For example, we can say, okay, this feature was intended to do this, this, and that, and we are going to reduce a little bit the scope, and so the feature will just address this and that. Or we can switch an item with another one that fits. If this item is too large, it doesn't fit in this sprint, maybe we can change with another one that is smaller and is actually easier to achieve. The team is autonomous. So the team is a sort of democracy here. The team has a meeting and decides in complete autonomy what kind of things is going to happen during the sprint. It doesn't need to ask permission to anybody. So all these things in a circle must be done in a sprint. So implementation and developer, so we start from evaluation, prioritization, detailed requirements, design and analysis, implementation, developer testing, quality assurance, acceptance testing. And you deploy and then you continue. Scrum is not just a mini waterfall, because in 2 weeks you don't have the time to split into a waterfall. So everything happens at the same time. So these are parallel activities, requirements, design, implementation, and testing. They happen at the same time in the team. Okay. Also, you have to understand that sprints are feature sprints. So the idea is not to produce a component inside a sprint, but it's to produce a feature. A feature means something that the customer wants. What does it mean that it must be complete? So what does it mean that it's done? So since every 2 weeks the release of the software must be done, team and product owner must agree about what this means. So what does done include? It must be coded, it must be tested, what kind of test? It must be documented, it must be integrated, it must be packaged. Well, all of this is not fixed. It's the team that decides what does it mean that the software is done. Whatever done means, the objective of Scrum is to extend the definition so that all these activities are done each sprint. So coded, what does it mean when the coding is done? Tested, what does it mean when the testing is done? And so on. The definition of done is chosen at the very beginning, so before the first sprint. And this phase is called the release planning. It's verified and updated at review retrospective meetings, and this happens after each sprint, and must be completely unrelated to requirements. So it must be a definition that has nothing to do with the specific requirements and the specific project. Okay? Then there is 2 concepts, sprint done and release done. So sprint done, as I said, at the end of every sprint you have to have a potentially shippable product increment. But release is when you're actually releasing out on the market the product, right? So very often release doesn't coincide with sprint done, okay? So it's like having 2 cycles, one inside the other, okay? So we are going to see how it does it work. But basically, there is a product backlog in which we put the item, and that has to be completed for the release. And at every sprint, we have to update this backlog to understand what is left to be done. Okay, so let's now look a little bit more in details at what is how a team is structured. So every team has three roles. There is the developer, the team developers, which is number 3. There is the Scrum Master and the product owner. So let's start from product owner. So the product owner represents the voice of the customer. So it's a sort of representative of the customer. Now, it must not be necessarily a person that belongs to the customer company. It may be also one manager of our company. But he represents the customer. He is responsible for the budget, so the amount of money that is going to be spent on the project. He is responsible for maximizing the return on investment of the development effort. He chooses release content and date, so he's responsible for choosing what a release must contain and when the release must be done. And he provides product visions and boundaries. So his job consists of talking to the customer and collecting basically requirements. Following the market trends, in case there is not one specific customer, is the one that looks at the market and understands what is needed. And of course, he works with the team. It must be a single person. It cannot be a committee. So it's one manager, one single guy. He must have a technical background because he has to interact with a team of programmers. At the same time, he must have a background that allows him to talk to the customer. So he must know what is needed to do the project. So this is one role that is actually quite difficult. He constantly reprioritizes and redefines the product backlog. Product backlog we'll see later on, but it's a list of things that must be done to complete the work. So it's a list of items that must be done. And so it has to do with the requirements because it contains things that must be done, so features basically, right? And since the requirements can change, this product backlog is the thing that changes the most. And who changes it? It's the team together with the product owner. In particular, the product owner prioritizes the items in the product backlog. So you understand what it must be done first, must be done later, and what is very urgent, what is not very urgent, what is very important, what is secondary and can be dropped. So it puts priorities on the product backlog. It is the final arbiter of requirements questions. So if there is some questions or requirements, is the one that decides must be done. Accepts or rejects each product increment. So at the end of each sprint is the one that says, okay, good, or no, this is very bad, we have to change something. He decides whether to continue development because he's in charge of the budget, so he's the one that spends money. He may also contribute as a team member. In some cases, it may be a programmer himself. Okay? There is a rule, he cannot be also the Scrum Master. We'll see later who is the Scrum Master. And if the customer or the business guy refuses to do the product owner, you can use an internal proxy product owner. So it must not necessarily be the final customer, but it must be somebody that interacts very often with the final customer. So it must be available. He must understand business, market condition, and customers, but he also needs technical skills because he has to work with the programmers. He must be communicative, so a good talker, not shy. He must be decisive, so he must be capable of making hard decisions. And so he must be mm, very sure of himself. He must be empowered, so he must have the authority to make decisions. So this is the product owner, and then we have the team. Team is the people that do the actual work, and historically this is called feature teams because it's important to make clear that they produce features and not internal stats. It must include not only programmers, but also some cross-functional people with cross-functional skills. For example, people that understand about business, people that understand about the domain. If we are working in a company that does then we have to have somebody that understands what account it is for. The team is self-organizing and self-managing. It means that there is not like a coordinator and a boss and the other ones are less or things like that. The only thing you have is maybe senior and junior, but you don't have a hierarchy of people inside the team. Okay, so it's flat. It has autonomy about how to reach commitments, so people decide autonomously what to do. And everybody must code at some point. So people who refuse to code because they are designers or architects and so they don't want to get their hands on a keyboard, they are not good fits for the team. Everybody must do everything and so must chip in, even if that requires learning new skills. So basically everybody must program. The typical size of a team is 7, maximum 9 people, including product owner and scrum master. So very small amount of people. It's not like 20 programmers. It's maximum of 5, 7 programmers, not much more than that. Also because otherwise it becomes difficult to self-organize. They must work together, so intensely collaborative. Typically, they are located in the same room. Most successful with full-time membership, so no members that go between teams or they leave after 1 month and things like that. So multitasking is forbidden. The team itself is responsible for communication and coordination with the external world, so no managers. In Scrum, there isn't any product management role. All project management must be solved by a self-managing team and the product owner. So the product owner is the only, let's say, manager on the team. But it doesn't decide how the team should work. It doesn't decide how things must be done. What it decides is the priority of the things, but not how the things must be done. The team must be one single entity, so no individual failures, only team failures. So self-managing teams means more productive because you don't need the managers to organize, and less latency in responding to change. So you have team members, and that's it. Okay, so attributes for a good team, we are going to skip this. So one curiosity is where Scrum, the word Scrum comes from. And this is not an acronym, but comes from the word of rugby. So Scrum in rugby is this, this thing. So this is called Scrum in rugby. And actually gives the idea of one single, a team that acts as one single entity. Okay, so very lot of emphasis on the team. The last role is the Scrum Master. So who is the Scrum Master? The Scrum Master is the one that supervises the Scrum methodology. So he's not a manager, but he's a sort of helper for the team to follow the Scrum methodology. So he's a sort of teacher. He helps the team in learning and applying Scrum. He teaches the team, the product owner, and the organization. His role is to remove impediments to the ability of the team to deliver the goal. He shields the team from external interference and distraction, and he makes sure to enforce the sprints, the time boxes. He has no management authority over the team, so he cannot decide anything. Okay. Also, he is one that can be fired by the team. So he's not controlling or managing the team, but on the contrary, the team can decide to fire him if he finds that the Scrum Master is not very good. So he provides guidance, not answers. He's not the leader, but just helps the team to accomplish the goal. And he has no authority, but only authority over the process. If needed, this role can be played by a team member. However, this is not suggested. It's better if the Scrum Master does the Scrum Master full-time, serving more than one team. So this is the attributes of a good Scrum Master. He must be responsible, he must be humble, collaborative, committed, influential, knowledgeable, blah, 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 blah. There is no project manager. Project manager is the worst choice to select a person to act as a Scrum Master. Okay, so if in a company there is the role of project manager and we want to switch to Scrum, the project manager should become a product owner and not a Scrum Master. Okay, other roles are stakeholders, customer, vendors, blah, blah, and managers. Of course, they are the managers of the entire company, which have to organize the company as a whole. Okay, last part is Scrum artifacts. So what Scrum is going to produce and what Scrum is going to use. So the product backlog, the sprint backlog, the release burn down, and the sprint burn down. So let's start with product backlog. It's a list of high-level items to be implemented. And this list is never complete because it constantly changes. Its content can come from anywhere. Users, customers, sales, marketing, customer service, engineering, everybody can submit items to the backlog. Okay? If you have multiple teams working on the same project, you have to keep one single list for multiple teams. So the backlog is just the list of things we have to do at the very high level. We then specify what more than how of a customer-centric feature. So they are just called items because it is a generic term which may include requirements, undone work, major improvement, and so on. It can be written in any form, so it can be a use case, user story, it can be natural language, it can be UML diagrams, whatever. Each item is characterized by a description, an estimate, which is the effort estimation made by the team, and a priority, which corresponds to the business value, and the priority is chosen by the product owner. Each item must be self-contained and independent of the others. So it must be a certain amount of work that can be done independently of the others. And the product backlog is kept sorted in order of priority. The higher the priority, the more urgent it is to complete that item. Okay? Okay, so we skip this. There are tools for a backlog. Typically, you can just use a spreadsheet. For example, Google Docs Online, that would be okay. Or you can use a whiteboard. To minimize rework, only the highest priority items need to be detailed out. So you can put some items which are urgent, then you are going to describe them more precisely. And some items that are less urgent and they stay lower in the list, they are going to be less detailed. At least 10% of product backlog broken in small requirements is fully analyzed. You sort the product backlog, you take a certain amount of item, and these are part of the release backlog. That means the next release is going to contain these features. Of this release backlog, you are going to detail about 10% more detailed because they are the more urgent, and 90% are less detailed. Okay, so yes. So to do work in progress done, of course, and we can. So release planning. Release planning happens at the very beginning of the first iteration that will lead to a release. And the purpose is to establish a plan and goals of the release. You create the first version of the product backlog, and you identify highest priority product backlog, measure risk, overall features and functionality that the release will contain, and probable delivery date and cost that should hold if nothing changes. Okay? So it's a very early meeting in which you decide what is going to be in the first release. Okay, you have to estimate work, okay? And when do you estimate? Okay, you start the first estimation on the release planning. Of course, the estimations are estimations, so they need to be updated constantly. So every time you meet to refine the product backlog, for example, in the middle of a sprint or at the end of a sprint, you estimate again the whole product backlog. Okay, and of course you have to look forward. So you have to think about 2 or 3 sprints forwards. So you have the product backlog. You take the first part, which is the release backlog, and you divide into sprints, and you do estimates, and you try to be more precise about the estimates that of the items that you are going to develop first, and a little bit less precise on the estimates of the things that have to be done later on. But every time you have to adjust this estimation, of course. Okay, so you can also do that relatively. So this is an example of a 2-week sprint. So at Monday morning you meet and you do the sprint planning meeting. You have a meeting to choose what will be implemented in the current sprint. So you take the product backlog, you go through the items, and you say, okay, these 4 items are the items I'm going to develop in this sprint. On Monday morning, Monday afternoon you start working. And you cannot work on Saturday and Sunday, okay? You meet at the middle of a sprint, so next Monday morning, and you do the product backlog refinement. So depending on what you did in the previous week, Monday morning you meet and you see if you have to do some adjustment on the estimates, and you understand if you have to change something in the backlog. And then you work through the week. On Friday afternoon, you have the sprint review meeting in which you deliver your potentially shippable product increment. So you deliver, and you do the sprint retrospective meeting in which you do feedback and you decide actions for the next sprint. Okay, so this is the iteration, 2 weeks. It's not much. At the beginning of each sprint, a sprint planning meeting is held. In this meeting, the work to be done in the sprint is selected. The product owner is responsible for declaring which items are the most important for the business. The team is responsible for selecting the amount of work needed to implement each item. So the product owner will tell you what is important. The team decides what to develop. So you take some of the items from the product backlog, you plan which one you are going to do in this sprint, and you put them into the sprint backlog. It's a separate document. Important, once you do this, you cannot change the sprint backlog anymore. So the product backlog is the document that is kept all over the project development. The sprint backlog is the document that drives the sprint and cannot be changed during the sprint. So you start breaking the features into tasks. The tasks specify how to achieve the items what. Typically a task will take between 4 and 16 hours of work, so small amount of work. Tasks are never assigned. There is nobody that assigns tasks to people. On the contrary, they are signed up for by the team members as needed, according to the team members' skills. It is better to only volunteer for one task at a time when it is time to pick up a new task. Okay? So the maximum amount of time, maximum length is 8 hours for a 4-week sprint. Reduces okay. So this. Okay. Okay, this is more details on the sprint planning meeting that maybe we can skip. It's important the sprint review meeting, which is at the end of the sprint. And the idea is to review the work completed according to the DOM definition. So present the completed work, so the software that works, to the product owner, the stakeholder, customers, executive, whatever. It's a demonstration, not a report, so they should actually see something running. So it's a demo that usually runs in a sandbox. It's important to make the product owner and the people try the software to collect feedback. So they should not only just see what happens, but they should be able to play with it, and so they can give suggestions. The management comes to see what the team was able to build with the resources it has been given, and customers come to see if they like what the team has built. So it's feedback. It's all about getting feedback on what has been done in 2 weeks. Of course, incomplete work cannot be demonstrated, and so untested software is considered not done because it's not shippable. And so you should avoid smoke and mirror demos because it's like putting all the dirt under the carpet, so it's not good. So not demo features, they are not truly done. Okay? If something went wrong, you have to accept it. So the team may be given more training, the team may be recomposed, more tools may be brought in, but it's important to understand as soon as possible what the problems are. Incomplete items are returned to the product backlog and ranked according to the product owner's revised priorities. Of course, people in charge of accepting, rejecting the software must attend the final review meeting of the sprint, and no one should prepare extensively for the review meeting. So to enforce this rule, PowerPoint presentations are forbidden because you should not prepare for the review. You should just concentrate on finish the work and then go there and show the demo. If the team feels that it has to spend more than 1 hour preparing for the meeting, it usually has less to show for the sprint that it had opened. It is trying to obscure this fact with fancy presentation. So no PowerPoint presentation. Okay? The meeting must be informal because what matters is the product. it must be a working meeting, so questions, observation, discussion, and suggestion are encouraged. And the Scrum Master is responsible for coordinating and conducting the meeting. So it basically meets with the team to establish the agenda and discusses how the sprint results will be presented and by whom. And item sends, okay, so it sends all attendants a reminder a week before the meeting, confirming the time, date, location, and agenda. And the maximum length of the meeting is 4 hours, but usually it must be much less. Okay, so we skip this. So this is the same figure as before. There are other meetings. For example, there is the daily scrum or daily stand-up. And this is just something that can happen at any time. It's a meeting between all the members of the team, the Scrum Master, and everybody else can participate. And it's something that is used by the Scrum Master to understand how the team is doing. So if there is enough communication, if people are getting well, if work is being done, if there's been some error, if the planning is okay, things like that. So what I have learned, this is the important question. Okay. Okay, and the sprint retrospective is after the sprint review. It's used by the team to meet and to discuss what happened. So these are private meetings, and it's up to the meeting to choose if other people can attend. And basically the team reflects on the past sprint. And the goal is to make continuous process improvement. Okay? So the idea is that the team talks to each other to understand if something went wrong and what can be improved in the process. Okay. Okay. A few other things that we can skip. And here you have a few references. So if you are interested in a Scrum, you can get some information to understand what Scrum is in this documentation. There are companies that provide you certification for Scrum and teach you how to implement Scrum in companies. This is probably not something that you need to do that here, but if you go work in a company, in a software company, it's important to understand what is this Scrum and what is Agile development, because there is a high probability that you are going to work in a company which uses Agile methodology. Okay, so and also maybe you can contribute to make your future company adopt Agile technology in its development process. Okay, so I think I will stop here. So just as a temporary conclusion, what we have seen in this course, it's a lot of things. We have done. We have gone from basics of C++ to a little bit of object-oriented programming and patterns, and way to use C++ more efficiently and more in a proper way, and finally we have seen also how to structure large software project using agile development and testing-driven development. So we talked about a lot of things in this course, I guess. I hope that you learned something by following me, and well, that's it. I'm waiting for your final project, of course. As you know, there will be 3 possibilities for the exam in the summer. We are going to have the first possibility for the exam is on the 18th. So I'm going to put an advice that the first exam is going to be on June the 18th, and then I think it's going to be also on July the 7th, and July the 3rd, the 30. Yes. So July 7, it's Monday, and then July 28 is again Monday. Okay, so as I said, 18 probably in the afternoon, July 7 all day, and July 28 all day. Okay, for the exam you have to provide me with the code of the project, hopefully at least one day before, so I have the time to go through it. And during the oral exam, I will ask about the project. We will discuss your implementation choice. You have to show me how the program runs and what you obtained. You have to explain me some of your design choices and why you choose one thing rather than another thing. And you have to, well, to give me reasons for developing in one way rather than another way. And finally, I will ask you some questions related to the course. For example, I can ask you something a little bit more technical, like, I don't know, what are, I can show you one piece of code and explain me what does it mean, or I can ask you to describe me what is, for example, I don't know, the P pattern and why this is maybe useful, or things like that. So basically, I'm going through the course and I'm just making questions of the things I have explained during the course. Okay. So that's it. I hope to see you at the exam. Let me know when you participate. I remind you that it's mandatory to subscribe to the exam. So there is a website. I think it's exam.ssup.it or exam.tsip.ssup.it, and you go there and you subscribe. Okay, so you have to subscribe. That's mandatory. So I can understand how many of you will just participate to each exam. Okay, do you have questions?
The exam will be face-to-face or?
Yes, face-to-face. I will be in Pisa. Okay?
Sorry, Professor, for the final project, you need some report, detailed report, or is enough our oral?
Well, a little bit, yes. So basically, if you write something that tells me how to compile, how to execute, how nothing very long. I don't want like 20 page of reports. No, please. So just read me with the basic things. You can, if you want, explain also the structure of the code if you want, but try to be short.
Okay.
So at most 2 pages in PDF.
Okay, thank you very much.
Okay? Okay. So if you have other questions, I'm always available via email. Okay? Also, if you want to show me pieces of code of your project, or if you get stuck at some point, or if you want some suggestions, you can send me an email, okay? It's not forbidden. Okay. So see you at the exam. Bye-bye.
Bye. Bye.